I'm done talk to all my tutorials, but I do not quite sure. Either my core lecturers doing the same thing. Double check the assignment. And today is the last day for you to key in your group assignment. For my tutorial, I'm done for the 9 sections. Okay, there are only a few, 1 or 2 number of students. She or he still has no groups for the group assignment, so I managed to help them. And I also got a few of requests from individual to say that they do not have the group assignment. I understand this is because of immigration visa case, and then they are being late join us in the week 1 and 2, but you need to manage that. So worst scenario, worst come to us if, let's say, you still have no group assignment. Next week, we try to take a look on and check on it. Okay? So today is the last day before the Friday prayers, 12:30. And another announcement that let's I share first. This one, my screen to the projector. What's the number? No number yet. Display. Connecting. A bit slow. Okay, class, let's see. This is your math time. And I did some of the changes for the latest news. You can take a look on this. There are many students still asking me the same questions about the midterm test. So our midterm test in the week 7. And that's the date. Okay, for your lectures, definitely on Friday. So that will be in another 3 weeks more. It's your midterm. And then that is a midterm format. Is that too? So you can read yourself. And then some of our students are saying, this is on paper physically. No, it's actually online. We want to use like an online. That's why we're practicing you for these 2 weeks using the My Time system, quiz. So the same thing. Is it, Indru? Is it? Did I say that? Yeah. Yesterday class? Yes. So, I don't know the others, but I'm going to let you know again. Because for those who are not belong to my tutorial classes, let you know, this is the midterm test format. And when? Another 3 weeks to go. What are the topic will be covered? There are 3. First chapters, and then I mentioned in my tutorial class, what are the things will be in the first chapters, only the G's. And then during my lesson, my lecture classes, today and yesterday, there will be. And then week 2, you learn about the numbering system, digital numbering system. And week 3, you learn about operation. So we also have the operation for the digital numbering system. It's combination, because if you want to perform any computation using these operations, multiplication, additions, subtractions, divisions, you need to convert that number from one base to another. But most of the quiz question, you will see we use what we call binary number. And I promise to you in the midterm test, I'm not going to giving you a fraction number and division operation. I did that, I mentioned. Okay, so for the lecture, I repeated again this thing. And what will be in your midterm test next week, we will go for, our lecture will talk about assembly language. So that will be the topic covered for your midterm test. All right? So this is the first announcement. So when I click in here, group assignment. A good news about the group assignments, after I did discuss with my core teams, okay, for the group assignment, the submission for the group assignment basically extended to another 1 week. Instead of week 10, and you can download the questions down here, not in the announcement tabs. You will see we have a question here. I already changed the date of a submission. Bloop, 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 bloop. Here. Okay, the submission will be week 11. Previous is week 10. So another 1 week we extend. What's the reason? Because we want to be fair to you, okay, helping you. Logic circuits, to simplify the SOP, some of our product for the algebra expression, it will take about the week 8 and 9. So you only have another 1 week to submit your assignment. And understand it's quite limited for you, so we extend to another 1 week. Is it fair, right? It's fair. And yeah, I'm really appreciate to those of a group of students. Some of them halfway, they are done their assignment. It's really great. Without my guidance, they can make it. I believe that they know how to draw the truth table, and then they come with the simplifications of SOP, and they try to group it in the key map. And after that, the last but not least, they are not done yet, which is the logic gate. So I have found that 3 and 4 number of students, they are done their group assignment. That's congratulations to you. It's really great. What I can do is only can check either that your working flow, the procedure you do for the truth table, for the key map, and the simplification SOP is correct or not. But I cannot answer. If you ask me, is this correct? The answers, okay? That's not fair. All right? So this is the thing, announcement for today, okay? I guess that I can start my class. So for today, what we will be doing, if you look at my time, you will see there are 2 slides for your lecture note, exactly like here, as well as in my laptop. You will see okay, here. One is instruction set. So if I open, this is PDF. And then this is basically cited from the books. You can referring to this. And then there are 24 pages. And what are the chapters we will cover for today? This chapter. 2.1, we're done. In the first week, we done 2.1. So I will not cover that one, because we are done with that. I will cover 2.2. And the most important in this case, which is 2.3. 2.2 and 2.3. So to ensure you understand 2.3 about the program execution, I'll supply you with another slides. Okay, so this slide has been created by Dr. Husna Sarira. I very appreciate to her. And then she trying to simplify that 2.3 just now, and then we come up with this slide. So this slide actually is helping a student to understand, I think, the most simplest way about the instruction set, how that instruction been fetched, to be decoded, to be execute, store, and it will be have a looping and on. So this is basically originally is from Dr. Husna. So Dr. Husna shared with us. So I'm encouraging you to use that, and we're going to use this for our lecture too. All right? So we'll start. In the first place, when we talk about this, what is the gist for today's class? I'm going to talk about the machine language, because after this we have assembly language. All right? So machine language, assembly language, all of this is a type of programming languages. Okay? Then I'm going to talk about program execution. And at 2.3, program executions will be asked in your final exam. Okay? Take a look on this. We understand in the computer architectures, you know about 2 types of architectures. And the first place, which is reduced instruction set. And the reduced instruction set, basically is the second of the architecture in the computer field. But the thing is, the most popular is a CICS, complex instruction set. Is this in your midterm test question? So the thing, when we talk about the architecture, we have two types. One is a CI, complex instruction set, and number two, we have a reduce. Okay, so you need to differentiate between these two. This is for your assessment, all right? So we understand that complex, we know that they have a one partition. This is the first, actually, it's been produced in manufacture, okay, by the manufacturer. One partition, one core. So some of people said core itself is the processor. I do agree. Some have said that it's a CPU. I do agree because CPU is a processor. So one core is a complex. But the thing is, we understand with the CICS, the complex instruction set, every single of instruction can be executed into, and they will go in and they will go out. Even complex, they can execute, but it takes a time. So after that, we have evaluation that we have a reduce, RI, reduce, to reduce the complexity, and there are many of a partitioning. So that's why we have many core nowadays, dynamic. So your current of a computer machine now have combinations of these two. So this one I did mention, okay, before. And then we talk about this one previously about the CPU, okay. Now you need to understand how that input or the data has been fetched, has been decoded, has been executed in our computer system, which is for the processor. So this one I leave it to you. The most important is this part, machine language. Okay, so is there any question about machine language later in your assessment? Yeah, definitely. So I believe that I settled this one. I just tried to Google and try to make it this is more simplest. This is the classifications of a computer programming language. Okay. The most popular question in the computer architecture is, what is a low-level language? 1 minute, take a look on this image. Like we see, there are two types of computer programming languages. There are, three. So we have a low-level language, middle-level language, high-level language. So what is a low-level language? This is a piece of a code of a program, computer program. Okay, same goes like what you are having right now. You have object-oriented. But what you learn, Java programming, C programming, C++, C#, Python, all this programming language is near to you. So there are a few of features between these three classifications. So we take a look on, I think, go to the high-level language, which is near to our language. Look at on the most of the right side of the slide. So high-level language, C equal with A plus B. Okay. So that is we able to understand, very familiar with this alphabet, and the operation is plus, equivalent symbol, and there is a semicolon symbol. We're very familiar with this. This is why we said this programming language is a high-level language near to user. So when we talk about low-level language, this low-level language, it is near to the hardware. So if high-level language is near to our language, English language, or NLP language, so think this one is near to the software. Because if you want to program, to develop any of a system or application, you need to install the software. So it's near to the software, it's near to us. But when we go to the low-level language, it's near to the hardware, to the IC, the motherboard. Okay, so that is a low-level language. And then we understand machine language. We aware that it's using binary to complements. So they're using binary. Look at to the most right, okay? There's a box, machine language, 100, 100, 11. We do not understand. If you're giving me this number, I still, like, blinding need to find what is this number representing in my language, English language. All right, so that's the low-level language, high-level language. What are the differences between these two types of languages? Okay, low-level language is quite complex. Okay, but this is what they are used, okay, to, set up, the manufacturer set up for their, what we call, computer architecture. I mean, I'm referring to the RI and also CI architecture. What are the things? If you look at to the low-level language and the high-level language, low-level language, to go to the high-level language, it taking in the middle another language as like, intermediator, as like a bridger. Okay, if computer have their own language and we have our own language, so we need to have an interpreter in between. Okay, before I go to the assembly language that we're going to learn next week, we go to the low-level language first. In the low-level language, it's not same like your language, high-level language. When we do produce any of a code program, okay, we want to come up with a system. You see, if let's say Java programming, you need to use that software, right? And then you do a coding, and you need to run. When you run the coding, what happens? If you have an error, it will show the error. Am I right? This is a high-level language. So we learn high-level language, it has compiler. Compiler is the functions to check either the piece of a code you write up in that simulator or the application, the software itself, it has an error syntax. And wonderful about the compiler in high-level language, the compiler function to interpret either that what type of error happened there. Is it the variables missing? Is that you are using wrong commands and you can't run again? So this is what you get in the high-level language. You have compiler and interpreter. So without the compiler interpreter, when you try to run, still is not display the result that you're looking for. And then you're going to try to figure out. And every day, I think you are burnt out. So this is what happened to me last time when I used Fortran and COBOL. When I used to be as a student, okay, you talk about 14 and 20 years back, I used COBOL and Fortran as my programming language, okay? So we don't have Fortran and COBOL, basically is in the middle of a language. Certain of version are using the first version, 1992, are using a first version. I did remember, when we have an error, what happened, we need to compile, run, and then try to find, and print out. It's like a bundle of paper, A4 paper, need to print out and see what is the error, what's the error. Actually, Fortran and COBOL, the first version, it doesn't has compiler interpreter. So we need to check one by one, line by line. Imagine we have a 300 of a line of a code. So they have a question, what's the compiler, what's interpreter? Where you can find that is in the high-level language. Okay, class? But when we talk about the low-level language, machine language, and assembly language, okay, nowadays, assembly language, you can Google, you can try the simulator. It has compiler and interpreter. But when I talk about in previous, the version, it same goes low-level language. Low-level language, it doesn't has interpreter and compiler. But a good thing about low-level language, it has assembler. The name also assembler. What is assembler? It's able to assemble all the instruction set following the symbol. There is a symbol. Okay, the symbol have a different functionalities. And in our topic today, we are referring to a description table. So this description table has been set up. We just follow. Okay? All manufacturer, for the computer hardware manufacturer, they're following this description table. And for us, And for you, the most important, you need to check the distribution table carefully. So this will be in your final exam question. How many marks? In previous semester, 20 marks. Some of students found it's easy. But I do not understand why. During the exercise, you're okay. But during the final, you couldn't get that 20 marks. So what is the problem? I found only one. I tried to take a look and investigate why students cannot score for discussion table, because we give you that discussion table, but still students lost the mark. And I understand students always make a mistake in the instruction itself. And another reason, because of there is instructions of jump and rotate. That's why students confused. And you are lucky this semester, your final exam, I'm not putting rotate, jump, even shift. Okay? Wonderful. So this is the first gist. Let's go the second gist. If you look at the second gist, for today's topic, instruction set, I go to this PDF. We're done with the machine language. Now we want to go to the process of execution. And we have what they call one of a concept in the process of execution in the computer system. We call that the store program concept. There is reasons why the name is a store program concept. So I'm going to leave you 6 to 7 minutes to try understand this video from the YouTube. And then if you are still not understand, it's fine. Okay? We're going to talk about that later during our tutorial session next week. Just try to understand in the first place. Okay. Take a look on this video. If I open this one, it's also mentioned here in the introduction, high-level language. Z equivalents with X plus Y. We understand this is kind of operation. There are two variables, which is X and Y. And then this X and Y variable need to be stored in one location, and the location is Z. And then in the computer system, when we talk about location, definitely is a register. Okay, it's a register. Number two, if we talk about location, definitely is a memory. So I did mention about the CPU units. There are what they call a group of register. So in this video, you will take a look how the input from the main memory will be fetched and executed by the processor, CPU units. And from this video, you can take a look what are the register in here. You will find there are a few new terms maybe for you, like an accumulator, AC. We have also PC, program counter. We have a memory address register. MAR, we have a memory data register. MDR, we also have a IR, instruction register. So some of students asking me, what is a register, Dr. Sari? I said, register is a type of memory. It's a buffer memory, it's temporary memory, it's a non-volatile, like a cache. So this is a type of a cache memory, level 1, level 2, level 3. So take a look at assembly language, which is, for me, this is a single assembly language. We have a single, double, and triple type of instruction. So this is the first type, because I have a load on my left, and after that, on the right, they have a value, 10, 11, 12. Okay, so we able to still understand assembly language, because assembly language is the middle language. Can I say assembly language is a low-level language? No, it's not correct. Low-level language only referred to the machine language, binary. Okay, so let's redo and take a look on this 7 to 6 minutes.
Location 11 to whatever's in the accumulator, and then high-level language. You should be able to get your head around that. Take the contents of variable X, add Y, and store the result in Z. If I was going to write something similar in an assembly language, I would need more commands. I need to think about the accumulator. So what we're saying here is load the contents of memory location 10 into the accumulator. Add the contents of memory location 11 to whatever's in the accumulator, and then store whatever's in the accumulator back into location 12. Referring to memory addresses by numbers is called direct addressing. Some assembly languages will allow you to use what's called symbolic addresses. So for example, I might say load X, add Y, store Z. That depends on the language. Once my assembly language source code has been turned into machine code, specifically once it's been assembled, it might look something more like this. You can see here we're using 6 bits for the operation code and 10 bits for the operand address. You might find something like this in a very old 16-bit machine. Now let's think about the registers inside the CPU. The blue box shows the CPU, and we can see inside there we've got a control unit, we have the accumulator, and the arithmetic and logic unit. We've also got some other registers, the program counter, the current instruction register, the memory address register, and the memory data register. And we're going to take a look at how these different registers cooperate to run the program. You can see on the right hand side I've got the memory, and the program has already been stored in memory. Now I think we need to take a reality check at this stage. First of all, the accumulator is actually a register which is part of the arithmetic and logic unit. But for the purposes of this demonstration, we've separated them. Secondly, the program wouldn't be stored as assembly code as shown here. It would be the machine code that's inside the RAM. The memory addresses themselves would also be in binary. And to tell you the truth, we'd be numbering from the bottom up. But for the sake of this presentation, we've distorted the reality a little bit. So what happens when a program runs? To begin with, the program counter stores the address of the next instruction to be fetched. In this case, the first instruction, which you can see is in memory location 100. Before we can fetch the instruction from the RAM, that memory address has to be placed into the memory address register. Once this has happened, the contents of that memory address can then be loaded into the memory data register. So we're fetching the first instruction now. Next, that instruction needs to be placed inside the current instruction register. Once it's been fetched into the current instruction register, the program counter will increment by 1. So the program counter is always pointing to the memory address of the next instruction to be fetched, before we've even executed this one. Now we can decode the instruction, and without going into detail, the control unit comes into play and it opens various pathways. The next stage in the process is to execute that instruction. The instruction is load 10, in other words, load the contents of memory address 10. So we're going to fetch something from memory address 10. So memory address location 10 now goes into the memory address register. Then we can take the contents of memory location 10 and place that into the memory data register, overwriting its previous contents. And then the contents of that memory address can be placed into the accumulator. That's the first instruction executed. Now we're going to fetch the next instruction. The program counter is already pointing to the memory address of the next instruction, so that memory address can be copied from the program counter into the memory address register. We can then take the contents of that memory location and put it into the memory data register. Now it will move into the current instruction register, ready to be decoded. But before we do that, we increment the program counter, so it's pointing to the next instruction. Okay, so it's time to decode this instruction. So add 11 is passed to the control unit, various pathways are opened, and the control unit makes sense of the instruction. So this instruction says add the contents of memory location 11 to whatever's in the accumulator. So this is where the arithmetic and logic unit really comes into play. An add instruction is passed to the ALU. The contents of the accumulator are moved to another place ready to be worked with. Now we can get the contents of memory location 11, and because we're going to fetch something from the memory, that memory address has to be placed into the memory address register. Once that's happened, we can get the contents of that memory location and place it into the memory data register. You're probably starting to see what the memory address register and the memory data register do. Whenever we want to get something from the RAM, or move something into the RAM, as we'll see in a moment, we must put its memory address into the memory address register. Whenever data, or a program instruction, moves to or from the RAM, it goes via the memory data register. So we have our number 3. That gets placed into the accumulator, and then the arithmetic and logic unit will add that to the 2 that we originally had and place the result back into the accumulator. So we're keeping a running total. It's accumulating the result. It might be worth mentioning at this stage that the circuits inside the arithmetic and logic unit are called adder circuits. They're actually very simple. The truth is, a computer is just a very sophisticated adding machine. Okay, so now we're ready to get the next instruction, which is in location 102. So the memory location 102 is copied into the memory address register. The contents of that memory location, in this case the last instruction, are copied into the memory data register. This instruction moves into the current instruction register. You can probably see what's going to happen next. We increment the program counter. We would probably have a stop or a halt instruction in that position. Now we can decode that instruction, which basically says store the result in the accumulator back into location 12. We're going to put something into location 12, so that memory address must be put into the memory address register, and the contents of the accumulator move via the memory data register into that memory location. And that's our program complete. Here's a simplistic diagram of the current
So if you look at to that one, you will see that there are many of registers, okay? And that register is a location to store any of the data in between the execution process. So that is the accumulator. That's one type of register, memory. And then you also have what we call memory data register. In the memory itself, such as like a main memory, we have another types of register. We call as a memory address register. So just to show to you, to introduce to you, there's a register and the process. If you look at the process, we need to have one register we call program counter. So this program counter will call the input, the data in the memory. And they use PC, program counter. And PC need to pass that data to be fetched by the bus system. So bus will pass that to the memory, what you call current of instruction register, CIR. Current register will pass to the MDR, data. So when they have this register location, they need to take the content of the register. So we know in the main memory, each of the partitions, it has the address, it has location. And in each of address, it has the content. So data is in there. So they need to fetch that data and then bring out to the CPU. Okay, to make it easy for you to understand, we go to the next slide, which is this one. Okay, so take a look. Machine language instruction set is from a topic of today. Okay, when we go to the next, this is the language description table. But for you, no need to remember all this. We're going to attach this in your final exam. Okay? So we're giving you this description table. The name is description table. It describes the opcode, the symbol. It's going to be like a secret code of machine language. Okay? It's like a secret code. Each of the codes has a number, and each of the number has their own functionality. Take a look on the slide. How many of a code we have? 1 to 9. So there's a secret code. Number 1 is forward, number 2 is forward, and so on. And then we have A, B, C. If take a look deeply about this description table, there are instructions. Okay? And each of these symbol, number 1, number 2, okay, they have different of a function. Look at to the first one, number 1. Number 1 for load instruction. Very popular. If you have an instruction, you want to load the instruction from the main memory. Just now you see, right, the execution, fetch. You need to load first that variable. But number 1, number 2, take a look 1 minute and read the description. It seems like similar, but the number is 1, the opcode. Opcode is stand for operation code, like a secret code. Okay? Computer understand by this one, the first number 1 and number 2 or number 5, number 6, number 7. This is the description. This is the task the computer need to do. Okay, when they have this instruction. So look at to the first opcode, number 1. Number 1 and number 2. It seems like similar. It has R, X, Y. Number 1 and number 2, yeah? And then next after that, you take a look on the description. Load the register for number 1. For number 2 also, load the register. Same. What's the difference between these two? To take a look on question, the opcode number 1. Load the register R with the bit pattern in memory cell address X and Y. But number 2, just load the register in XY, the value itself. Number 1 and number 2 is totally different. Even instructions, secret code is same, load. But number 1, you load the memory address, the address of memory. Number 2, you load the content in that memory address. So this is another example. I want to show to you students having a mistake, especially A. Look at to A, opcode, and B, opcode. It's quite complex, but I mentioned to my student during the final exam, even next week tutorial exercise, read the description table, just copy and paste the sentence. We not ask you to memorizing, try to understand overall, but the things, just copy. Okay? So now, this is description table. I done introduce to you. Let's we go to the first step. I give you an example also. How we going to do this? How we going to do this? Executions of instruction, set of instruction. Why is not moving? Okay, it's moving now. Introduce to you in the set of instruction in computer, it must has first opcode, the secret code, the opcode. Okay, the opcode always in the first digit. Okay, the first digit of that instruction. Only 1 digit. And the digit will be 1 to 9, A, B, C. Only that. That is opcode. So computer will understand, oh, with this number, this is what I need to do. With that number, that's what I'm going to do. So it's opcode, secret code. Next is operand. So what is an operand? Operand, the description about that opcode. What that task computer need to do, operand. And this operand has a two types operand. Okay, take a look on this. One is a register. And I said to you last week, even the first week, whenever that we want the computer need to execute, then it has a register, which is location. So register is a location, memory location. So operand have a 2, register and bit pattern. So opcode, normally opcode including register and bit pattern, the contents must be 4 digits. The first most in the left will be the opcode. The second after the opcode will be the location, register. And the rest depends. Sometimes will be the variable. You want to add the first number to the second number and so on, bit pattern. We call that is a bit pattern. Remember, second gist. Next gist, the third gist. We look at to a few of example, instruction set. Okay? First of all, 1 load. This is from description table. I copy, paste in your bag. 1 RX, Y. Take a look on that. Can you please take a look on that? I copy. from the description table one by one to show to you. We have a 1. Of course, 1 is the opcode. R, just now in the description table, is register, location, X and Y. So what is this X and Y? For number 1, X and Y is a memory address. Again, memory address. So what is instruction? Load. So if I want to understand carefully before I go to write down the execution to check, okay, I'm going to see the opcode number 1. I go opcode number 1, I put in 1. And then I see R. R stands for register. So normally the question like this. Look at to the second sentence, load register 2. So I see, oh, is a load register 2. And number 1. So number 1 is the opcode. I refer to description table, I see. What is description? I just copy. Okay, register. Load register. See the second and the first sentence. Load the register R. Load register 2, the question said. So you just put 2 in register. With the content in the memory cell address B1. So B1, another 2 bits will be at the end, B1. So that is the first example of the instruction set following description table. So computer understand, oh, this one, any of content later in memory cell B1, I need to take fetch and put in the current instruction set. But where I want to put? In 2, register number 2. So that is the first. Let's go next. Example. Next example, if you look at the description table, we have load also, but number 2. This is why I said just now there is a difference. Number 2, I copy from description table the first sentence, 2RX. So I know the first opcode, the first digit 2, I put in the opcode. I refer to description table. Description table said RXY load the register R. So I need to load register R. What is register R in this question? 2. So copy 2 and put register R as the value 2. And I said with the value B1. So the content is a B1. This one is a B1 is a content, just not the address. This is the content. So that's the difference between load number 1, number 2. Okay, never mind. We hold that. No need for you to struggle to know about this. You need to do practice. After this, I give you an example. Number 3, for a store. I copy from the description table, store. Number 3, to keep and save and store. Store, computer system understand this set of instruction to keep and save the number in particular register, particular location. So this is the description in the description table. I copy paste. It says 3RX store. I mean, computer need to store the bit pattern which is they found in register R, current register, in the memory cell, address this one. So in this question, store register 4 with the value bit pattern found in C2. So I mean, I found that is the data, the input in the memory C2. So my bit pattern is C2. My register, where is it? This C2 is in the register 4. Currently, I need to store here, and I'm using opcode 3. So computer understand, which is the data in the C2, the current register 4 holding need to be stored in the register 4. So it's the same to the rest. Okay, we have just now 1 to 9, ABC. Okay, just now, if you cut to the video in the YouTube just now, where I shared, okay, the program counter increased 1 time, 100. Then after they done execution of the first of instruction, they go for the next, right? Load another 102, increase 1 time. Okay. Normally, in the final exam questions, basically in the computer architecture, is following how many of bits patterns of that operating system. How many of that? Some, they catch and execute 8 bits. Some, they catch 16 bits. Some 64, some 32, some 128, if a fast hand computer, right? Okay, take a look on this. I'll leave it to you this, and we will do exercise later during the tutorial. And for help, Okay, for the help, if you take a look on the description table, I forgot about that one just now. C000, C000, opcode C, it means stop. Stop, the execution done. So it will be 000, help. Okay, we take a look, one example. This question. 1 minute and read. This is an example of a question. How many marks? 10, 20 marks, kind of that. We can have many questions about this question. I mean, we can have a B, C, D questions. But in this case, I just make it A, B. Take a look what the daughter's Husna write down in here. Never care about the question A and B. We read one by one the sentence. Okay. You've been given the address and the content of the address. The address memory 001012030405. And the content inside that address 21, 0B, 14, 04. If I asking you, where is the locations of CO? You know, CO is in the address 04. If you combine these two, memory address and also memory data address register, the content itself, these two is 4 bits. Look at that, 4 bits. 00 include 21 is a 4 bits. If I combine 01, 0B is 4 bits. If I want to take, increment, program counter, incrementations, 21 and 0B also possible. So if I combine these two, I have a 4 digits bits. 4 digit bits, it means hexadecimal. So we understand hexadecimal is being used for the operating system. Therefore, we're going to have a program counter incremental 2 times. Okay, in the exam question, this is very popular. Our lecture was set up with a 4 bits. Why is a 4 bits? Look at the description table, also 4 bits. Yeah? So what is the question? The following table show a portions of machine memory, which is it's containing a program written. The programming language, machine language, describe the language description. Okay? Answer the question by assuming machine going to start to do execution in the PC content 00. So I mean I'm going to start with 00. Where is the 00? Is the first address. The question might be asked you, start with 02. Maybe a question asks you, start 04. So next week, tutorial, we will see a few of addresses and the content. So see the question, start where? Okay, maybe 00, maybe 01. So in this question, 00, we start with address 00. Okay. Ignore A and B. We'll see how you're going to come up with the solution, yeah? The most important, which is the table, the long table just now, you can see that on the right side. That is the most important. You need to have 1 column for program counter, and the next increment of a program counter, PC, and then the current of a register, location, description. 4 things. Okay, take a look, the first one. So I copy and paste back, which is this is address on your left side. That is the address. Okay, this is from the previous page. The address 00, 01, 02, 03, and so on. And that's the content. Copy and paste here. So easy for you to refer. Okay, the answer basically, general purpose register. That's the answer. Let's take a look one by one. One by one, slowly. Okay, the question says it start with 00, right? So we start with 00. So what will be the value of your program counter? 00. So that's why you will see it has 00 there. Because it starts from 00. The question start with 00 address. So you put in the program counter 00. And then when you look at the address 00, the content is 21. So you push 21 to the current register. This is exactly what that video in the YouTube just now shown to you. So 21 put in the current register, IR, CIR, 21. And then we are done with the 21. And then I said it's 2 just now, 4-bit, so increment will be 2. In the YouTube video just now, it showed increment 1 because the bit is 2 just now, so we make it 1. The other one is here is we have 4. So we're going to have increment 2 times. 2 times. In YouTube video just now, only 1 number. So increment only 1. Here we increment 2 because 4 bits. Okay, it is a 4 bits. See, 1, 2, 1, 1, 2 here, including this is going to be 4. 21, 0B, 1, 2, 3, 4. 4 bits. So increment will be 2. So when you increment with 2, it means excluding address 0, 1 and 0. Sorry, 0, 0 and 0, 1, including these 2 address. Okay? Because 2 increment. Once you're done with this 21, and the increment will be 2, right? You need to include 21 and 0B. 21 and 0B will be in your register. Just now you have 21, right? Including that 01 address, 0B, so you will include that 21, 0B in your IR. So now I have a complete 4 digits of description table, instruction set of a computer. So I have a 4 digit, I will go for my description table and see the first of the bit and the most left, significant, number 2. Go to the description table, number 2. Have opcode number 2? Yes. 2 is for load, but load the content. So when you refer to the description table, later, you will see number 2 is a load the register with a bit pattern. That is the instruction description for number 2. Copy. Copy that. Load the register. What will be the register number? Here is 1. Second bit is always register. The first bit on the left will always your opcode. After that will be your register location. So copy number 1, register 1 with the bit pattern. Copy the rest. Another 2 bits balance, 0B. So the description will be complete. Load the register 1 with the bit pattern 0B. Finish the first instruction. So when you said load register 1, look at the general purpose register. This is the address number 1. So load 0B to that address memory. So register number 1 have a content 0B. Down there, the table. So the first instructions, load register 1 right in here. Load register 1. How I get 1 from here? Always the first digit, the most left will be your opcode, secret code. Number 1 will be register, location. So that's why it's a register 1. And then what I need to register, what I need to put into this register, the bit pattern, the content of 0B. So I go to register 1, I go into create 1 table, seem like memory partition. So I just set it that 0, 1, 2, 3, 4 and so on. And there's register 1. So you can see register 1. What will be the content? Bit pattern 0B. So that's what you can see here. Next, program counter is a 02. So you bring to the column of program counter. Okay? So you refer to the address, memory address 02. You have a 1, 4. So when you have a 1, 4, incremental is a 2 times. So the arrangement will be 1, 4 combined with 0, 4, which is going to include 02 address contained with 03 address contained. So that's why you see in your IR, the current instruction register have 4 bits of the content in the address 02 and 03. So you will take a look on the current IR, 1, 4 combined with 04. So that's why you have 1, 4, 04 in the IR columns. So before I going to translate this as what is a discussion, I need to make sure my program counter increment next. So 02, 04, 06, 08, and so on. Increment 2 times. YouTube just now increment 1 time. This one 2 times because we have a 4-digit hexadecimal, so we increase to our program counter to the 2. So now 04. I already update my program counter. So now I have a responsibility to translate this code 1404. So I go back to the description table. The first of this IR, first bit on the most left is 1. So I refer to the description table number 1 opcode. The number 1 opcode is a load the register. But we're taking memory address because in description table, number 2 also load, but load the content. Now number 1. So I refer to the description table, I will got load the register. So after number 1, the next bits after the opcode always register. So I copy number 4. The register 4 with bit pattern found in address memory. After the 4 register, next bit pattern will be 04. I copy 04. So now it said load register 4. I look at to the bottom of the table. You draw the table and then locate address 4 with with 04. Okay? So if you look at that, load the register with bit pattern 4 in the memory cell 04. See the current 04 is a C0. So that's why in my executions table, as like in operating system, then the CPU will show that in your arithmetic logics unit, register 4, yeah, memory cell 04. So 04 is a C0. So my current of the accumulator will map the location 04 with this contain 0. Okay, 4, we have a C0 here. So this is what happened. Now continue 04, program counter, back to the program counter 04, refer to the 04. So 04 increment will be have another 2 increment in this case. So we have 04. But 04, okay, this is the thing. 04 is a C0 combined with 05 register contain C000. So that's why in your IR now becomes C000. How? Stop. So what is this one? If you look at to the discussion table, this opcode with these bits 000, stop. So that's how you stop. So when they stop, done. This is just example, simple example. In your final exam, no, it's not simple. Look at to the question. What is a bit pattern? Will be in the register 4 when machine stop. Register 4, the answer's C0. Next question, what the bit pattern in register 1 when machine off or stop? So it's a 0B. Done. So I also can have a question, other questions about this. We're going to further this one, the discussion. Your lecturer, my core teams will help you during tutorial. You can ask. So this is just the general to show you how it's done. Okay, dismiss this class. Thank you. Attendance. So make sure you key in your group names in the group assignment Excel sheet. We already deal. Whoever not key in, your name is not there. Assuming that you are not submit, then 0 mark will be awarded. We deal the first week and second week, right? Fair. Okay, class attendance. Okay, if you're done, you may leave. Thank you so much. I appreciate you are coming for today's class. Thank you.